So today we're going to be starting our last unit, and we're going to start by actually looking at a circle and talk about some of the things that, since we are not actually doing the circles unit, there is some information from the circles unit that we're going to need in order to do this last unit on trigonometry. And I know that seems kind of odd because trigonometry, that was right triangles, and what do circles have to do with right triangles? But trust me, it's important. So when we are looking at a circle, there are a couple of different things that we talk about when we talk about measurements on a circle. So you may remember that the distance from the center to the circle, that's called the radius. And then all the distance all the way around the circle, that was called the circumference. And we also know that all the way across the circle through the center is called the diameter. So just to make sure we have all of our vocabulary going on here. And so today what we actually want to talk about is not the whole circle, but pieces of a circle. So you may recall that a circle has 360 degrees all the way around it, from starting here and going all the way around to the other side. And that is the measurement of the degrees swinging around this central point. Now, when we talk about the actual circle itself out here at the edge, all right, we have two different terms for the way that you measure parts of a circle. So when we have a piece of a circle, there's two ways that we can talk about it. There's two ways that we can come up with a numerical value for that piece of a circle. One is called arc length, and one is called arc measure. And I know that that seems kind of funny. Isn't that the same thing? But no, those are actually two different measurements for the same thing. So when we talk about an arc is just a piece of the circle. So, you know, the whole circumference is the actual circle. The circle is just that rim around the outside. If you're just taking a piece of that circumference, a piece of that circle, that is an arc. So the arc is right here. But the way we measure that arc could be in two ways. One, you can measure the actual length of that piece of the circle. So think about if you had string going all the way around the circle and you just cut that little piece of the string out and then stretched it out straight and measured that piece of the string. This is the arc length. So it's a linear measurement. Something like centimeters or inches or meters or miles, something along those lines. When we talk about arc measure, we're actually talking about what is its piece of the circle here at the center. It's an angle measurement. So arc measure is what is the angle at the center of the circle that is created by that arc. If I take a radius from this end of the arc and a radius from this end of the arc, what is that little angle right here at the center of the circle? It's called the central angle, appropriately enough. What is its measure of that angle that arc fills up? So the arc measure is an angle measurement. And up to this point, we have only had one angle measurement, and that is degrees. But there is actually another form of measurement. Interestingly enough, the other form of measurement came first. Who knew? So we're going to learn a new measurement for angles, and we are going to actually talk about how do we find arc length. So we're going to start with arc length because that's something that we're fairly familiar with, and coming right off of the equations and stuff that we did at the beginning of this week, conveniently enough, it involves proportions. So yay for that. See, I told you everything fits together. So we studied, solving proportions on Monday, and now we're going to actually talk about how we can use that to help us with arc length. So when we talk about arc length, we said that it's that piece of the circle. out here. So we're just taking a chunk out of the circle's circumference. So it is the circumference of the circle. And what's interesting is that the proportion that this piece of the circle is compared to the circumference is the same proportion as this arc measure, the angle measure at the center, is to the whole circle. So when we're trying to find an arc length, all we have to do is set up a proportion where we put the arc's length in a proportion with the circumference of the circle, because it's part of the circumference, and it has the same relationship as that central angle does to the whole circle. And we know a whole circle has 360 degrees. So if, for example, I know that this circle has a radius of 5 centimeters, and I know that I'm cutting out a piece that has an angle of 36 degrees here at the center, I can figure out how long that piece of the circle is. All I have to do is set up a proportion. So I want to know how long is this arc. So I'm going to make it X out here. Okay, so it's going to be X, and it'll be in centimeters because the radius was in centimeters. So the arc, I don't know what it is, but I can find the circumference. We know the radius is 5 centimeters, and if you recall, circumference is equal to 2 pi radius, right? 2 pi radiuses. So that means that I'm going to say 2 times pi times 5. So that's going to be my arc to my circumference. Well, I also know that this arc took up 36 degrees out of the 360 degrees. So now I have set up a proportion. So now I can reduce this fraction, which will help a lot. Let's see, this is going to be X, and this will be 10 pi. And then this will actually, both the top and the bottom will reduce by 36. So this is actually going to be 1/10. So if I cross multiply here, I'm going to get 10x is equal to 10 pi. And then if I divide by 10, oops, not 100, 10, I'm going to get that x is equal to pi, or approximately 3.14 centimeters. All right, so that is how you can set up a proportion to help you actually find an arc length, the specific actual measurement. And this is where you'll just want to be very careful on IXL and on any test or any quiz that you take in the future. Make sure you pay attention to whether it's asking for an exact amount or an approximation. If it wants it to be exact, you just leave it as pi centimeters. That's not rounded. Pi, is the whole decimal. If they ask you to round to a certain decimal place, then you just plug pi into the calculator and round it to a certain decimal place. But you're going to find that we tend to like to keep pi in there. It's easier to do the math than it is with the decimals. So I usually keep pi in there until the very end, and then depending on what the question is asking for, that's when I decide whether to plug it into the calculator or not. So now I want to talk about another form of measuring those central angles. We've talked about degrees, but degrees have not been around that long. Actually, a degree is a pretty precise measurement. You've taken up a circle and you've taken this whole distance all the way around, and you've split it into 360 equally tiny little pieces. And so, precision instruments and stuff like that have not historically been around nearly as long as mathematics has been around. And so early in mathematics, they had a different way of measuring those angle measurements. And interestingly enough, they were based off of circles. We did use it for angles and other things like polygons and triangles and stuff like that. But the actual first original way we came up with measuring angles came from a circle. And so today I want to talk about the other way of measuring that, and that is a radian. All right. If you recall, when you first started doing trigonometry on your calculators, we talked about it's so important to always go into the settings and make sure it's on degree and not radian, because those are both just different measurements. And you want to make sure the setting is on the right one because it's using different numbers depending on which one you're using. And that is still going to be very, very important. But where did this radian come from? So that's what we're going to be looking at here. So let's take a look at this animation. So let's say we have a circle of a given radius, and we want to take that radius, and we're going to take that exact same length, and we're just going to stretch it out along the side of the circle here. And what this makes is 1 radian. Okay, so a radian, the definition of a radian, is the angle formed when your arc length is 1 radius around the circle. And that's why it got its name, radian. It's a radius. It's the angle you get from 1 radius length around the circle. And so if we look and see how many radiuses fit around the circle, you can get a couple. There's 2, and then you can get 3, and then there's just a little bit left over, and that's what makes it be pi radians. 3.14, 3 full radiuses, and 0.14 of a radius, and that's actually pi radians. And in fact, all the way around the circle, if we keep going, we get 2 pi radians all the way around the circle. And this absolutely makes sense if we just think back to, we were doing arc length, we talked about circumference is equal to 2 pi radius. 2 pi times radius is 2 pi radiuses. That's how many times I can get around the circle. It's 6 and a little more than a fourth, 6.28. Radiuses to get all the way around a circle. And so the circumference of the circle, the whole circle, actually takes up 2 pi radiuses to get around the circle. So that means that in measurements of angles, you get 2 pi radians around the circle. So just like 360 degrees is the complete circle, 2 pi radians is the complete circle all the way around. So a radian is the angle formed on a circle by using an arc length along the circle's circumference of 1 radius. The circumference of a circle is 2 pi r. This means that there are 2 pi radiuses in a circumference, which is to say there are 2 pi radians in a complete circle. Now, it is a little weird when you first start dealing with radians because your whole life you've been dealing with degrees. So we do need to think of how do we go back and forth between measuring in radians and measuring in degrees. So that's fair. So we do have to have a conversion. And doing conversions, that's going to be really important in your science class next year. So we want to make sure that we keep up with our conversions. But it's important to know that 180 degrees, half of the circle, is equal to pi radians. That's exactly half of the circle. And so if we're doing a conversion, all right, you want to think about what are you trying to get rid of and what are you trying to keep, all right? If I am trying to get rid of radians and get degrees, then I'm always going to multiply by 180 degrees over pi. So these two are equal to each other, remember? Pi and 180 degrees, that's just equal to 1. So when you multiply a value by this, you are, in essence, just multiplying it by 1. But what it's going to do is it's going to cancel out the radians in this number and leave me with degrees in this number. So this is how I want to convert from radians to degrees. Now, if I happen to have degrees and I want to convert them to radians, then I want to multiply by pi over 180 because, again, the degrees will cancel out and it will leave me with the radians. So this is going to be from degrees to radians. I will also say that generally when we're dealing with radians, we keep the pi. We don't like decimal radian numbers. We tend to keep the pi in there and keep it exact. That's actually one of the reasons that you will find upper mathematics uses radians instead of degrees, because you can be exact with radians and get a fraction and not just decimals. And we love exact answers in mathematics. So we do tend to use radians more than we use degrees. Science tends to use degrees more than they do radians because science also understands their instruments can only measure up to a certain decimal place anyway, and so they tend to round to whatever decimal place their measuring device can do, which also makes sense. So we can convert, if I know that something is 75 degrees and I want to know how many radians is that, I would just multiply it by pi over 180 degrees. So what happens is I get this lovely proportion, or this lovely ratio. It's going to be a fraction, and we want to just reduce the fraction 75 divided by 180, and that reduces to 5/12. So 75 over 180 reduces to 5/12. And I'm multiplying it times pi, so it will be 5/12 pi. You may also see that written as 5 pi over 12. That's the same thing. We do want to leave it as a fraction, but again, always read directions. If they ask you to round to a certain decimal place, by all means, type in pi and round it to that decimal place. If I happen to have 3/8 pi, or 3 pi over 8, and I want to know what that is in degrees. So if I've got 3 pi over 8, I'm going to multiply it by 180 over pi. Well, notice what happens when we multiply those. The pi's actually cancel out. So here's another reason that we like to keep the radians in pi form, because the pi's easily cancel out, whereas with decimals, not so much. So now we need to figure out what is 3/8 times 180. So 180 times 3 divided by 8 is actually 67.5 degrees. And with degrees, we do tend to use decimals. So this is how we convert back and forth between radians and degrees.